Welcome to the MAKE course. I'm Rudi Schlaf, a professor at the Department of Electrical Engineering at the University of South Florida. In this video I will discuss a few basic features of Autodesk Inventor and show you how to use them, and I will also talk a little bit about how to design specifically for a 3D printer. And I will do this at the example of a small lighthouse. Before we get started, I wanted to show you this pretty picture of a classic lighthouse. So this is what I'm inspired of when I now show you how to make a model of a structure like this. Okay, let's get started with our lighthouse design. So the first step when you start a new design is to click on New here, and then it gives you these templates, and by default it is in English templates, and so it will start dimension everything in inch. I like to go to metric and select this one here typically. So it's in millimeters, which is good for 3D printing because outside the US everything is in metric units, and so is also most of the 3D printing software, etc. So it's good to be in millimeters, but that's just my preference. So let's click this here and then say create, and so now it gives me a blank space here, a blank volume in which we can start to draw. So over here in the feature tree, as they call it, we have now not much, only this origin here, and here it basically gives you the 3 planes of the coordinate system and also the coordinate axis. Now for 3D printing it's good to start on the XY plane because that doubles with the printer bed. So I select this here and then I make my first sketch. So in fact you see here when you just hover over something with the mouse, it will give you a little box here like this one that tells you what this tool here is for. And that's very convenient when you get started with the Inventor. But anyway, let's click here on Start Sketch, and so it basically put now a sketch on that XY plane. Right, you see here where we are, X and Y. And the first step, I want to make a little base for this lighthouse. We make a rectangle, and so I choose here the one that we can define with the center point and one point in a corner. There are others, right, that you could select from. Okay, so here let's dimension this 50, and with the tab button you can get into the other input box here without mouse clicking, and so now we have a 50 by 50 square, and that's all we want here for that base. So we can finish this. And if you click here on this house, it will put it in the standard isometric view. So let's extrude this now. So this here is the extrude input window, and basically I just selected this profile this loop that I just made, because there is only one loop, and then it suggests here 10 millimeters. Since we're building this for a 3D printer, I print in 0.3 millimeters layer thickness usually, and so it's good to make this here in multiples of 0.3. So let's select 6.9. I believe that can be divided into a clean number of layers, and I say OK. And so now we have the slab onto which we can place our lighthouse. So I like to actually rotate this now into an orientation that is natural for the lighthouse. And now we need to make our second extrusion for the lighthouse tower. And since this is rotationally symmetrical around the z-axis, I'm gonna make my next sketch on the XZ plane, on the YZ plane. Let's do that. And I start the sketch, and so you see it now put it flat, that the sketch is flat on the screen here. But for my first step, I like to turn this a little bit so I can see exactly which edge I'm now gonna choose when I project the top of the base onto my sketch. And this I do with a construction line. So here you turn on construction lines, and so I select this corner, and you see now it made me here this dotted line in my sketch, which coincides with the top of this base. So this is a very important feature here, project geometry, when you start using Inventor and make drawings. Okay, so let's turn this here off, and now it's good to go to slice this and place it flat again for this to draw our next loop. And we go back into the sketch environment, and with the line tool here now we can start a shape. So let's do this. So the first step is always you do your basic shape for your sketch, and then you use these constraints here, dimensions and constraints, in order to nail this down in exact engineering dimensions how you want it. And so the first step here may be to define the angle of this cone segment, and so let's give this 85. And we also want the distance here, right, from the center. So let's make this, okay, 17 is good. I could have just let that be. And then what did I do? Okay, so here I want this here parallel to the base. So you see here with this tool I was able to constrain this to be parallel. The same I want here between these two, I want them to be parallel. And you see now how these lines, one after the other, turn black. This means a black line is basically constrained already, while the other ones, they can be still moved around with the mouse. Right? If I wanted to move this here, I cannot do it anymore, because it's now constrained with this dimension. So it's good to make sure that the entire sketch here is constrained before you extrude it. So what's missing here, of course, we need to define a height, right? And so let's make this 60. And now it went outside the screen, so with this button here you can zoom out, that just everything fits in again. So you see now there's still one left here that is purple, and so this also wants a dimension. So I can just grab this line here and put a dimension on it. And let's make this 2. Why do I 2? Because 2 is a really great sidewall thickness for 3D printing. It usually comes out in a high quality without any funny wiggles and stuff. When you go thinner, it can stress the 3D printer a little bit depending on the model you have, and so it doesn't look so pretty anymore. So 2 is a good number for a wall that you print upwards. Okay, so this is fully constrained now, it's fully black, and that means we can finish this sketch, and now we can extrude it. And so we don't use the extrude command now, we use the revolve command, because we want to make a cone segment. And so you see now, because we have only this one loop, it selected it again, it's black already, but we still need to define an axis. That's why this is red and has that little exclamation mark triangle here. So what do we select here? Where do we want to rotate about? Of course the z-axis. And so we select the z-axis, and you see now it slam bang made us this cone segment. So we can OK this, and you see already how this lighthouse is growing on us. What you also see is that here in the feature tree we have now 2 features already. This first extrusion for the base, and then the next extrusion, this revolution, that defines the lighthouse tower. when you click on these pluses here, you can actually see which sketches are associated with these features. This here we call features. So an object is always composed out of a bunch of features, and each feature is based on a sketch. Okay, so by the way, if I wanted to change the height of this, right, if I want to make it 65 millimeters, you can just double click here on the sketch and it comes up again, and then you can here edit your dimension. So let's do 65, makes it a little higher, and I finish, and you see here now it updates it. So this is really nice. You can go back and update your dimensions to make things fit your need. Okay, so what's the next step? Well, now we need to make this top of the lighthouse with the lighthousing, etc. And so the next step is perhaps to put here some kind of platform on. So I want this to jut out now a little bit to make a slightly bigger platform. Then this tower is wide up here, so we make this with a new sketch, and of course we make it again rotationally symmetrical, so we can again select the XY plane and start a sketch on it. Oh, this was not what I wanted. I selected the wrong plane. So the back button is really your friend in this software. So let's go back to this and select the correct axis. So what I really want is here a plane that slices through the tower. So let's use this one here and place the sketch on it. And so you see it rotates it again, that it's flat on the screen. So in order to project our geometry, we need to rotate it a little bit. So with project geometry again and turning on the construction lines, we can now project these two circles onto the plane, and that's basically what it did here. Is it generated us points on our sketch that we can use now to base my next loop that I'm drawing here on it. And so the first line that I draw is by selecting this point now and this point, and so you see I have this line here, and now I make something, let's start here, that juts out from that cone segment, and you see here already it gives me now this parallel constraint that you see here moving around a little bit as I hover with the mouse. If that's what you want, and that's what we want here, we can accept this and click here, and so you see now it's already automatically constrained to be parallel to the line down here, and now we can close the loop. So this is our next shape that we want to extrude, but of course we need to dimension it first. So the first thing is, this is the most important constraint here, define the angle, because this here now will jut out from this tower, and when you print something like this, you cannot go much steeper, much flatter than 50 degrees or so, especially when the object is round. So I'm gonna just give this here 55. I hope this will print well, and let's go with that. And so now we also need to define again the height of this. So yeah, let's make this 4 millimeters. That's nice. And the next thing is we need to define the angle of this here, but we can, I think, just make this parallel again. So will be interesting to see how this prints. It's slightly challenging. So let's finish it, and of course we could use the revolve command here, but I like to demonstrate the sweep. The sweep basically allows you to move a to extrude along a line. I cannot move my mouse while I'm up here hovering. So what you see here is basically this red line, that could be defined in another sketch, and then this loop that's here in green can then be extruded along the line, and you see that yellow here next to it, what would happen if you did something like that. But here now, of course, we only have these two lines here we can extrude along with the sweep feature, so it will do the same like revolve basically, but let's just see what it does. So here again, the profile, the single profile in the sketch has been auto-selected, but we need to select the curve. Okay, so now let's select this one here, and you see it also does a revolve here basically, but using the sweep feature. I just wanted to show you what this feature does. Normally I would have used the revolve probably. Okay, so now we have this jutting out base, and now let's put a floor on it. So the next step is to select this here. So now I selected just this plane basically that's defined by this feature. So that's another way to place a sketch. You can just put it on any plane that you have on your object already. So with the project geometry, of course, what I want now is, because I want to put a floor on it, let's rotate this a little so we can see what I'm selecting. So I just select this here, and this is all we need, right? So it made me now this yellow circle that matches up exactly with the base that I generated with the previous feature. So let's finish this, and now we can extrude it again. And since we're extruding in the Z direction, we need to do again here something in a multiple of 0.3 to make the printer happy. And because now we're going over an empty space, we need to have a few printer layers in order to get a smooth surface, because gravitation will mess up the first few layers, and they will sag a little bit. So in my experience, 10 layers or so is good to recover and create a nice flat layer. So let's put 3 millimeters in here, so this will give us 10 printer layers. Okay, and so you see now we have here a growing lighthouse. So the next step is to put a structure on here to house the actual light. And of course what we do again is put a sketch on here and project the outer circle here, the outer perimeter. That basically has the result that this center point here is defined. And so that allows us to put the next loop here centered on the on this platform. So let's make this 20 millimeters, and here now of course we need to print a wall, right, because it needs to be empty inside. So we make another loop and we place that in here, and now we can dimension it depending on the outer loop by just clicking on these two, right? And so we can now give it my favorite thickness again, 2 millimeters, and we say OK. And now we need to extrude this again. And so now you see here actually both are red. Select profile is red because now here we could select this here or this here. So of course it doesn't know which one we want to select. And here now it's a little tricky. Sometimes it does that. There are actually 3 choices, right? You could select all inside this loop, all inside here, but only in between also. And sometimes when you can't do that, then zooming in helps a little bit. To tell it which closed area you want to extrude. Okay, so let's click on this here, and it selected here 3 automatically because that's the last distance that I entered. But let's make this maybe 15 millimeters. Let's see how this looks like. No, not 15. Well, 15 is that 9 plus 6. Yeah, okay, so 15 should work in printer layers. And okay, so this is maybe a little bit too high. So let's change this. So I double clicked on extrusion number 3 here, and I'm just putting in 10. And here. Okay, so this is now the base for our housing for the actual light. And now we need to put some kind of cage feature on here so the light can actually emit from this space. And for this we make our next sketch and we place it on top here. And again we project and construction line on, and we project this here, and we project this here, and construction line off. And now let's define here a segment that we can extrude. So let's put an arc here, and you see here now this little arrow with the red line that constrains this arc directly to match my my projected geometry here. So let's do that, and we can put one on here also, and we accept this auto constraint. And so the only thing now that's missing is we need to define an arc segment, and so we can do this, and then we can use this constraint here, the coincident constraint. And you see here, you see here, this is not on this line here yet. So I click on this and I click on the line, and you see here now it just popped it right into place. Here it is already, I think, and here also. And so now the final thing is we need to close this loop, and for this we turn the construction line off, and we go here and we close it here. And so now we have a segment that we can extrude, but it's still not fully constrained because we have these two purple lines here. So with the with dimensions, I define an angle between these two, and let's do this 20. And so this is still not fully constrained. So let's see what the problem is here. So by grabbing it with the mouse, okay, you see here this is not constrained yet. So how do we do that? Okay, one thing we could do is we could put here another helper line that is just on the y-axis, and then we can use this constraint here, the collinear constraint, and constrain it with this. And now we are done. There are always several ways to do this. This may not have been the most perfect way like I just did it, but hey, it got it done. And now we can extrude this feature, and let's make this maybe 20 millimeters. This will be interesting to see how this prints, because when features get small, then these printers can also get challenged a little bit. But anyway, here we see it now. We have our first feature of that cage, and so now I'm gonna use this super cool circular pattern feature, and I'm gonna simply rotate a few of these here around the center axis. And so we leave it here at features because this is what we want. We want to make a circular pattern out of a feature, and here in the feature tree we select now this feature, right, that we just made. So now it's selected. But we still need to select a rotation axis, right? You need to tell the software around what axis now it should group these features. And so we select here that we want to select a rotation axis, and of course we use the z-axis, which goes right through the center of our lighthouse. And so you see now it suggests here to do 6 of them, which I think looks pretty good, but of course you could also do 7, right? So, but let's stick with 6. And if you would enter here 180, for example, then it would group these 6 around 180 degrees, but that's not what we want, right? We want 360. And we say OK, and now we have basically our cage. So now we just need to place a top on this, and of course that we do with another sketch. And so this one we put again on a vertical axis, and so vertical plane, and so we use the XZ plane, and again need to project something. So I'm doing this here with the mouse wheel, just zooming around. It's good to have a mouse that you can zoom with a that has a wheel. So if you don't have one, I would definitely buy one if you want to get into CAD drawing. Okay, so now we need to project again our top area here, and we can, for example, do this here. Oh, I forgot to turn on the construction line feature. So we can also here right click on it and then say construction, and so now we have a construction line that we can use to base our sketch on. So I want to make this a little bigger, so let's just expand this a little. And again, I forgot to turn on construction line. This can be sometimes, oh, back button. So let's right click this here, construction, and let's make this here in line with this. And so now we can okay, this was all stupid. So the back button is your friend. I should have really, what I should have really done is projected this here. Perfect. Okay, so now, because this already gives us these 2 points here, and this is of course what we want. So now I can draw my next loop. So let's just put a roof on the thing, and so okay. So now we need to do a little bit of constraining. So the first thing is I want this here on the z-axis, because we want to rotate around the z-axis again, and you get already the idea. I just want to make a pointed circular round roof. So the last thing we need to define here is the height of it. So let's do 6.9, and that is our shape for the roof, our sketch for the roof. So let's use the revolve and select the z-axis, you know that already, and bang, we have a roof. Okay. But I see an issue now with printing this. I think what I really would want is to also have here a little just a base onto which to place this roof, so we can revisit this sketch here and make this a little different. So let's slice it, and what I really want is a shape like this, so we delete this one here, go back into the sketch environment. Now let's do this and this, and now we need to constrain, so this and this, and here we put 3 millimeters to it, and now we make this a little higher. So to make it look like before, you can just say now plus 3 millimeters, so you can always put formulas in here. This is actually pretty cool. You can also make formulas with other dimensions. So what we could do here is, we could also, instead of saying plus 3, we could say plus this dimension, and then OK it. And so this would have the effect that this here now would be based on this. So this is what you see here, fx, it always says it's based on something else. So we could basically change this here now into 2.7. And you see here it updated this here automatically now based on this here. So that's a very useful feature for if you design more complicated things. Okay, we have a loop, and you see here now how it automatically updated it. Since I still had only one loop, and I just modified this one loop that was extruded here in this revolution, it didn't get confused, and so it just updated the feature. And so we have a nice and pretty lighthouse here. And I think we leave it at that, and let's see if we can print this. But I should save this perhaps. So, because I did one in class already. So let's make this version 2. And let's export this for the printer. So basically what you need to do there is to get a printable file, is to go to export and CAD format, and here it's already auto selected because I usually have it like this, but you need to, usually it comes up with a DWG file pre-selected, so you want it as an STL file, right? STL, that's what the slicer for the 3D printer can understand. And one more thing, if you do this for the first time, you need to go into options and select millimeters here. Otherwise it will export it in, I think, a 10 times bigger or smaller size, I forgot now, than what you draw it on the screen here. I don't know what that is, but anyway, if what you get on the printer is 10 times bigger or 10 times smaller, it's time to go into this option here and select millimeters. Okay, and with this we can save this, and then we can go over to a slicer and put this on a printer bed. Alright, here we are in the slicer software. I fired up Cura. That's a software provided by the printer maker Ultimaker, but you can also use this for any other printer. You can define your own parameters up here, but I don't want to go into this right now. I just want to demonstrate to you the basics here. So let's put the Lighthouse on the printer bed. Okay, here it is. So basically what I did is I clicked on here and then selected the file, the STL file, and so it popped up like this here. Because we started designing it on the XY plane, it's already in the right location. If it isn't, you have these features here where you could actually rotate it and place it. But for us, this is good in the middle of the printer bed and flat on it and upright. And so now we can just click on slice, right? So I select your 0.3 millimeters layer thickness, and I also selected my printer, which is a Monoprice Ultimate, and we click on slice, and so it slices it. So it says it will take about 2 hours and 6 minutes. That seems realistic. So what does it mean, sliced? Basically it now cut this object here into slices that the printer can print. And when you use this feature here, you can actually here look at individual layers, right? And so you see how the printer will put down one layer after the other until you have your entire model printed. Okay, let's print this. Okay, here we are at my Monoprice Ultimate printer, and this here is a time-lapse video, so it covers about 2 hours and 20 minutes maybe, and it will just show you now how this Lighthouse prints. Let's do it. I'm sorry that the video was a little bit out of focus. So here a nicely resolved shot of our Lighthouse. So you see all the features came out pretty nicely. It was able to go out here, make an overhang. Remember, the important part here was that the angle should be 50 degrees or steeper. It also fairly successfully did this cage here, and I'm actually surprised how well this came out, but I guess it's a good printer. So overall, a pretty successful 3D print. Okay, that's it. Thanks for watching.